two series of a total differential type of questions in terms of partial differentiations. If you want to go back to the previous video, click this one. I will highly recommend. If you want to click to my playlist and look at other stuff that might be fairly helpful to you, click this link over here. Okay? If not, let's continue. Ta-da! In the cold processing plant, the flow V of a slurry along pipe is given by this equation. If R and L both increase by 5% and P and N decrease by 10% and 30% respectively, find approximate percentage change in V. So how do you solve this? The keyword over here is find the approximate percentage change in V. So if you were to remember from my last video, we have approximate and the actual value approach. In this case, we are going to talk about approximate approach, and thereby we will have du is equals to, we have 4 variables as you can see. Let's identify for you. The first thing you need to do is to identify the variables. So identify the number of variables. I have 1, I have 2, I have 3, and I have 4, right? And this pi is just some values, 3.142. Okay? And therefore we have 4 values. We just partial differentiate them in terms of their own stuffs. So I have partial V, partial R, dr, plus partial V. Actually, this is dV lah, okay? This is dV. Partial L, dl, plus partial V, partial P, dP, plus partial V, partial L, dl. Is it dl? Ding 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 ding. Ding 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 ding. It's actually dn. Alright, dn. So this term, this whole term is for R, this whole term is for L, this whole term is for P, and this whole term is for N. Alright, so this is the thing when you're talking about the approximate solution. Right, the general equation, I believe you have understand how it's being applied. So the previous one I believe that you have understand. But anyway, I just write it down. So partial u partial x dx plus partial u partial y dy. This is the general equation. If you have more variables, this is why we have 2 more variables over here. This is generally the thing. Alright? And therefore, what we can do is simply to partial differentiate this stuff, just sub it in. And then this dr, right, this dr is, later on you'll get to see what the hell are the things in terms of percentage. Alright? So I'll just do up partial V and partial R. I think it's fairly easy. So if you don't know anything about differentiation, I suggest you go and watch. Never mind, I'll just do it up for you together. Anyway, so let's just do it here. Okay, I should paste this over here better. So let's just differentiate in terms of R. So partial V partial R is equals to, if I differentiate, I'll have 4R cubed, okay, pi P 8 and L. That's all I'm doing. I'm just differentiating the R. That's all. Okay. Now I differentiate partial V partial L. So L is at the bottom. So what I can do is just to bring that dude out. I can do this mentally, but I'll just share with you the method so that at least you know next time how do you do mentally. -1. I'll differentiate, I'll bring this down, I'll have minus pi p r4 8nl minus 2, and then I differentiate the inner one, I would have 8n, and henceforth I have minus 8n pi p r4 divided by, because this is in terms of minus 2, a minus 2 is equals to 1 over a square. That's the meaning of that. So that's what I'm gonna do right now. Therefore I have a n l bracket square. Be very careful with bracket square, okay? This is very key understanding. You're gonna don't write like that, okay? You're gonna kill yourself. You're gonna do that. Alright? So now we're gonna do in terms of partial v, partial p. Alright? We're going to do up two terms. Alright? These two terms. Therefore let's continue with the p. And therefore partial v, partial p, I have in terms of p, which is the numerator, so that's good. Let's differentiate. I just clear it away and that's it. Nothing fancy. And then last but not least, partial v, partial n is equals to, is it partial n? Right, it's partial n. And therefore is at the denominator. I just write this down again. I bring this differentiate minus pi p r4 8n l minus 2. Differentiate the inner one. I will have 8l because now I differentiate in terms of n. Right? Therefore, if I were to rewrite again, this is exactly the same thing that just now we have done for when we are differentiating in terms of L. Okay, so now these are the four values. I'll just rearrange them neatly so at least you can see them better. I have this one, okay, this is partial v partial r, this is partial v partial l, this is partial p partial partial v partial p partial v partial l, partial p partial n, sorry. Yeah, so the rest is the same. So this is exactly the same thing as what I've written over here. Okay, this is the thing. Check it out, it's exactly the same. Okay, I'm just subbing in the stuff that we have done earlier. I'm not cheating you any feelings. Alright, I'm not lying you. So now, how do you find the percentage? Normally the percentage is taking something that has changed. This is a symbol for change, divided by its initial stuff. I call this v in this case. Right? So something that has changed already, which is this one, which is this one, right? dv is equals to the one that we have just shown you earlier. So this whole thing is a change of v, and you're gonna divide the whole thing by its initial formula v, which is that holy formula, this v. So each of the term I got somewhat, this one throw away. How do I throw away? Just put it here. Yeah, anyway. So each of the term I'll just put it below. Alright, because v is equals to this term, and individually if you know the rules of divisions and stuff like that, it's a very simple. But also for simplicity wise, I'll just put it over here. Okay, if you want to let it look at least quite like a neater way, then this is the one. Okay, and therefore we have this form. Okay, in other words, this form is also partial v over v. I mean dv over v, the changes in v divided by initial values of v's. Okay, and then we're gonna cancel them one by one. You're like, what the hell are you gonna cancel this thing? How the hell, right? So let's do together. It's kind of quite straightforward, and later on you'll see a trend. When you get that trend, you know that you're damn safe. Alright, I cancel this term with, maybe not lah, okay, I cancel pi with this dot pi. Alright, I cancel this with the top one, the numerator cancel with the numerator, and the numerator with the denominator. The denominator is the same, so I just cancel each other already. And then I'll have r cubed cancelled, and this one is left with only r. And therefore this term, we can happy write it down as 4 dr over r. Okay, plus, now let's change a different color. I just cancel away the denominator, so I cancel away the square, and this thing gone because denominator and denominator cancel. And then PR4 and PR4 cancel, pi cancel, and we have left over, we have 8n over 8nl, right? So this 8n and 8n cancel, so we have minus dl over l. Okay, I know that this is like what the fuck, right? But when you're doing it, you'll know that it's pretty straightforward. Or nonetheless, if you find that it's confused, go back, click back at like 30 seconds ago. You can just rewatch the thing. Is, yeah, hopefully it helps. Anyway, so now I cancel again. 8nl cancel. R4, I know that they are the same, I cancel. Pi, I cancel. Now I have left with 1 over 8. This is 1 over 8. dp over p. Right? This is pretty much that, my fault. This 8nl cancel with this 8nl is totally cancelled. I don't know what the hell am I doing. Never mind, let's just remove this. Okay, so I have this thing over here. And then the last color, what should I pick? I think you want to pick pink, right? Let's pick pink. Okay, so now we do this thing again. 8nl cancel the square. Okay, and then hope you know what I mean, and hope you understand what I'm doing right now. Okay, because for example 1 over a square divided by 1 over a, I'm simply cancelling this with, okay, I just write it in terms of divided by 1 over a, right? Is equals to 1 over a square times a. I cancel, I have 1 over a, which is what I'm doing right now over here. Okay, it's the same analogy. If you don't know what the hell am I doing, I apologize if you really don't understand what I'm doing. This means I suck. Anyway, so PR4 cancel, pi cancel. Alright, now 8l and 8l cancel. Then we have n and dn, right? Now, do you see a very familiar trend now? Not familiar, but rather than something that is very nice, right? So in terms of dr over r, dr over l, maybe I should highlight better. dr over r, dr over l, dp over p, dn over n. You know, if you have these things without any other forms, like maybe we have some n over here and some r over here, if this is the case, then you're wrong. Alright, if you see very clean, all wow, like nice only, you know, then yeah, you're safe, you're on the right track. So what the hell is this term dr over r, dr over l? What are they talking about? These are the individual change in percentage. Alright, if you remember back the questions, they have said that the r and l both increase by 5%. This means there is a change of 5%. Alright, 5% is in terms of 5% is equals to 0.05. Alright, if you don't know what I mean, if you were to 5% is equals to 5 over 100. Alright, is equals to 0.05, right? That's all I'm talking about. Therefore, this is 0.05 increased by 5%, so it's plus. and then minus dr over L. L also increased by 5% as being shown here, so we know that, yeah, so dr over L is also 0.05 plus dp over p. dp over p, it states that okay, p decreased by 10%. So if you're talking about decreases, so p decreased by 10%, and then n decreased by 30%. So we're going to talk about minus, alright? So we have minus 0.01, not 0.01, 0.1, sorry, 10% plus minus 0.3, right? I forget one sign. You see there's a minus sign over here. I actually forget to put, this is also a minus sign, but I bring it down over here, but I forget to bring this down, you see. Therefore I should change this a bit such that it is better. Here you go, minus, and this is also minus. Okay, and therefore if you evaluate or anything, you have 0.05 times 4, you have 0.2 minus 0.05 minus 0.1 minus 0.3 is plus 0.3. You would have 0.2 plus 0.3, 0.2 plus 0.3 is 0.5 minus 0.15, you'll have 0.35 equals to 35%. So the answer is 35%, and it answers that the approximate change in terms of the flow is 35%. So there will be about somewhat 35% changes in the flow, which is pretty good. So as you can see, the approximate approach is somewhat okay already, instead of the accurate approach, because accurate approach sometimes may be a little tedious, and we're talking about flow, sometimes it's very tough to actually accurately measure the flow and things like that. And yeah, so I think this is a pretty good setup of exam questions, and I hope that I give you the key intuitions. So first you will identify all the number of variables first. This also applies to your partial differentiation, your chain rule and stars. Alright? And then next you're gonna partial differentiate in terms of whatever thing you want. So you remember this formula, alright? Not this all the variables, but rather than the key concepts that I've mentioned earlier. And then also this one, try to see that if you have this type of trend already, you know that you are safe. That's the meaning. And then you get the answer. So I hope that it helps, and I shall see you in the next video. Bye bye.